Okay, I just want to check these thoughts another way. And I'm going to, in a moment, draw a right triangle where legs A and B are given. A is 4 and B is 7. And we're going to find the values of sine A, cosine A, tangent A, and then sine B, cosine B, tangent B. But just as a quick refresher, don't forget that when you're thinking about a triangle, while yes, this is called the angle theta, and this is the side opposite, don't forget about the x, y, and r idea based on the opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent. So don't forget, for this angle theta, the sine of theta is the side opposite over the hypotenuse, or here, y over r, as we've shown here. Don't forget, I need to have you memorize these definitions, and you'll repeat this on the first page of our test. This picture right here would help you get the x, y's, and r's without memorizing them. But let's go back to this thought up here to kind of connect the dots. Let's say that we had a right triangle, and now I'm just going to draw this right triangle in kind of an odd way. That's my right angle right there, and I'm going to connect, this is the hypotenuse. So here's my right angle. And so side A is 4 and side B is 7. So that's these two legs. So I better make this side A, which is 4, and therefore this has got to be angle A. And I better make this side B, which is equal to 7, and therefore this angle has got to be angle B. Remember again, the 90-degree angle is angle C, and the hypotenuse is side C. So I laid this out kind of funny, so you'd have to kind of turn your head upside down to write the definitions for sine, cosine, and tangent for angles A and B. So let's go ahead and write the definitions. So the sine of angle A is defined as the side opposite it, which is this 4, over the hypotenuse. Oh, wait a minute. I don't know what the hypotenuse is. So let's figure that out. Legs of 4, leg of 7. So put it into your calculator, into your program. If you didn't have the program or didn't have that tool, you'd go ahead and square the legs, add them together, and in the theoretical world, 16 plus 49 is 65. A lot of people would use the hypotenuse as the square root of 65, but it's also approximately equal to 8.1. So we'll write it in several ways. So the sine of angle A is the side opposite over the hypotenuse. The proper way is 4 over the square root of 65. But not quite proper because I'm not rationalizing the denominator. I left a radical in my basement. I'm not going to worry about that right now. Another way you could write it is 4 over 8.1 because that is a square root of 65. And finally, you could take 4 divided by 8.1, and I believe, I hope I have that somewhere in my notes. When you do that, 4 divided by 8.1, and actually I did 4 divided by the square root of 65. I'm going to do 4 divided by 8.1. And as a decimal number, you get 0.494. If you did it as 4 divided by the square root of 65, you get 0.496. So a difference in the thousandths place. Not to worry, but I want you to, when I show you something else here, I want you to see the difference here. The cosine of angle A is equal to the side adjacent, the 7, over the hypotenuse, the square root of 65. Or you could write it as 7 over 8.1. Or you could write it as 0.864. I like to write these to the thousandths place. Remember, these ratios represent these fractions. This is the exact form, but these are all the ways you can write the value of a trig function. The tangent of angle A is the side opposite over the side adjacent. So that's the 4 divided by the 7. And if you wanted, you could go ahead and take your calculator and get 4 divided by 7 is 0.571. Now, I want to come over here and I want to write the definitions for the sine of angle B and the cosine of angle B and the tangent of angle B. So remember, sine of an angle is side opposite over the hypotenuse. So here's the angle, the side opposite over the hypotenuse. 7 over the square root of 65, or 7 over 8.1, or, 0.864. The cosine of angle B is the side adjacent to it, the 4, over the hypotenuse, the square root of 65. Again, you could write it as 4 over 8.1. You could write it as 0.494. Or maybe that's 0.496, I'm not sure. 4 divided by 8.1. Yeah, that's 0.494. The tangent of angle B, side opposite over side adjacent. So this one is 7 over 4, when this one was 4 over 7, and that's equal to 1.75. Could I remind you one more time? Would you notice that the sine of angle A, which is this, is equal to the cosine of angle B? Very, very same thing. Could you notice cosine of angle A is the same thing as sine of angle B? So if this was a 30-degree angle and this was a 60-degree angle, if you took the cosine of 30 and the sine of 60, you would get the same value. Lastly, I want to remind you, from any of these trig functions, doesn't matter which one, but I'm going to use this one. From any of these, for this picture where A is 4, B is 7, and C is 8.1, if you know that the sine of angle A equals 4 divided by the square root of 65, don't forget your tool that you can find the size of angle A by taking the inverse sine of 4 divided by the square root of 65. And when you do that, you get the size of the angle. It doesn't matter if you used sine to get this 29 degrees, or if you use tangent. You could use tangent here and go inverse tangent of 4 divided by 7, and that will give you 29.7-ish degrees. I'm showing you how to do this. I'm not able to show you the calculator usage on my screen because I don't have a calculator, the software here at home. But again, you hit the second key and then the sine key to do this. That will give you the inverse sine. I believe it opens parentheses for you. Then you go 4 divided by, you don't have to use square root of 65, you can use 8.1. Close the parentheses. When you use 4 divided by 8.1, that one gives you 29.59 degrees. Awfully close. Just reminding you of how to use your calculator. Again, given these two sides, I was able to write the values for sine, cosine, and tangent for the 3 trig functions for the 2 acute angles. When we come back, we're going to solve a right triangle where I gave you an angle. It's going to be this problem right here, where I've given you an angle and a side. So you're going to be given this angle A is 18.4 degrees, and this is angle C, you know that. So this is side C is 3.72. So you'll be given these 3 pieces of information, and from that you're going to use the definitions of sine, cosine, and tangent in order to solve for the unknown pieces of information in this problem, which would be side A, angle B, and side B. That's where we're headed to next with all of this.